Just a minute, please. My name is Nikolai Ryzhikov. Probably my presentation is a bit unusual. I am Samurai team manager. We develop a medical platform and application on it. And we even devised a profession of holistic engineer. So it's not just a full stack, because full stack is back and front, but we make full stack plus DevOps. So we do everything up to business analytics. It's an interesting and universal approach. And our three main technologies or areas of work are Postgres, Clojure, and FARIA, that is an open medical standard. Each of us has their own community, and we develop these communities. And here I decided to develop an experimental talk. I will speak about the way we work with Clojure and Postgres. And mostly, I will speak about Clojure. My presentation will be interactive in Emacs. You can see the code of my presentation on GitHub. Here it is. There is a library and there is slides folder. So if you want to try it, you will be able to execute everything that I show today. So let's start. Clojure is very small language. So we may learn it within 5 minutes. I guess that many of you do not know it, but it's quite simple. So, for your reference, I'd like to tell you that Clojure is a functional list that can be hosted on JVM or JavaScript runtimes. This language was devised by one person, Ryzhikov, and in my opinion, this is a very serious thinker. Of our age, we have Michael Stonebreaker, and Ryzhikov is quite similar to him. So please find his presentation. You can listen to such lectures as Simple Made Easy or Programming in a Hammock. These are very serious talks. Clojure. How can we understand that? Well, you can think of any dynamic language that you know. JavaScript, Perl, Python, Ruby, and after that, we start computing. We start removing the extras, and after that, we will get this Clojure. This is a small conceptual language, but it's quite powerful. I think that this is a king or a queen of dynamic languages. First of all, we get rid of syntaxes, because this is Lisp. That's why we do not need it. After that, we remove mutability. Most data structures in Clojure are mutable, persistent. It means that we can write on Clojure in a functional state, and actually not all Lisps are functional, because in Clojure the main data structures are immutable. It means that most part of your code will be pure functions. After that, we remove classes, objects, and other issues. In Clojure, we used only generic data structures, maps and vectors, and functions, that's it. And we also remove the difference between design time, runtime, compile time. We interactively develop this program, you will see it today. This is repo-driven development. So we actually interact with runtimes in an interactive manner. This is the way we develop this program. And remove all other features that doesn't function. We only have functions and data structures. So it's like a matrix. Before learning to read Clojure, you need to understand that this is a Lisp. The Lisp is built on as expressions. So you can see that in route brackets, this is a formula and an argument. So you can put the symbol or you do not have to put it. And this is the way we will write down operators, functions, and macros. This is a form. For example, let's imagine that we call this function. How will it be written? We just put this bracket in the beginning and remove commas. So we are calling this function. I executed it, and now we can see the result. And I did in a similar way with the operators. We put the operator in the beginning, place everything in round brackets, so we can remove the extras. And this is the way we call the operator. So if you think about it, actually it looks like AST. If we parsed it, if we used C-like language, this is like a node, this is a parameter. If, quite similar, we take the round bracket, transfer it, and the operator is in the round brackets. In Clojure, almost all these expressions return. That's why we would not have to write return. And this is symbol x, value 1, the value of the variable. So we can substitute 1 by 2, and the result will differ. So how can we announce the function? There is a specific formula, defn, the name of the function, these square brackets. I will explain you what it is. Here we have arguments, so you can place a common, but you do not have to place it. And this is the body of the function, a and b, and here we are calling. I hope that you can understand it now. In the beginning, it's quite difficult to get used to these brackets, but after that, if you count the number of square brackets and punctuation marks in your language, you will understand that there are fewer syntactic structures in Clojure, and it also gives you an opportunity to fulfill structural editing, so you can remove a lot of things, you can shift them. So we announced the function and we called it. Let's go on. Clojure is very small. It is the first function to host. That's why, first of all, we need to understand that these functions are taken from host, and if we are using GM, we can see a primitive GM. So this is a string from Java. And there are several special strings. So there is a string that starts from colon. This is a keyword, and keywords are used as keys for hash maps. And here we can use MySpace. And also there is a symbol. So when you write it this way, Clojure is trying to resolve it, but this is a primitive data type. This is a string, and it is used to store the names of functions. So these were primitive things, and there is a small amount of inbuilt data types. Vector in square brackets. So I guess that you are well aware of this array of vector. We announced it, and here there are a lot of operations. For example, we can take an element, and we can add vector. Here, we can take everything apart from the head. We can remove the last one. There are a lot of functions here for working with vectors. And there is a list. It should be written in this manner or in this manner. Actually, by writing code as a data type, you will not work with it frequently, maybe only when you write macros. But in principle, this is a collection, this is a sequence. So here you can see round brackets, and this is a list. This is the essence of the list, because we have data in the brackets. That's why microsystems, the opportunities of extending the language, that is quite natural for Lisp and Clojure. But actually, quite frequently, we do not write macros if we do not really need it. And speaking about this list, we can execute some operations, we can add something, it is added in the beginning, and there is a specificity here. But when you write lists, this is a list as well. The first symbol is ANS, the second one is L, and Clojure executes it. Okay, so here we can collect code. This is the way you write macros, so you can collect your code. There are sets. This is an ordered collection, an ordered sequence where all the elements are unique. For example, we can add a string, nothing is changed. We can remove number 3. There are dozens of functions for working with sets. And of course, the queen of our data structures is hash map. So this is an object. We can put a comma here, we can write it down this way.
We can add thousands of functions or dozens of functions, or we can remove the key. We can merge two marks, a lot of functions out of the box that help you operate with these structures. All these structures, when you change them, you have a semantic of copying. When I did merge here, I got hold of the new map, but the old map remained as it was. You have an illusion that every time you get a new one, but it's a tricky thing inside. It looks like a guide, and it costs you almost nothing. You can write in the functional style because all your major data structure are mutable, so they can be clean. It may look that it is not so important at the start, but when you start working with it and realize how much nicer it is to operate with immutable functions, with clear functions. You may face concurrences as well. At some point of time, Alan wrote about epigrams in an article, and he collected a set of proverbs, and he said it's better to have one structure and 100 functions on top of them instead of vice versa. In Azure, we have 4 data structures, 500 functions, and 100 macros out of the box in order to work with data. Here we see the range. We filter and get 10. Double arrow is a macros. You can reverse it. It makes a simple thing. It takes the first expression, put it in the end of the second one, take this expression and put it in the end of the third expression. This is how it works. It's better to read it because it's a stream of ranges. So don't be afraid of this macros. This is called shredding first. The next expression is inserted into the end of the following expression. So we can work with a map. We have map with an address, and inside there is an update. Again, a lot of functions that help you transform data, change data, run across data. At this point, so we have learned 80% of the system. We have primitives, basic data structures, and clear functions on top of them. 80% of your code, nothing in excess of this. And this is the wonderful simplicity of Azure. There is one more important thing, which is REPL-driven development. What you see is that I value the code, I perform it. Everybody is saying that in many languages there is REPL, and it is imperfect, but it's a tool with which you work. In the morning, you launch REPL and develop a program in the same fashion as I did. So you insert expressions, and you'll further see how it is being done. But for this to work, you need to know several tricks. For example, when we announce a function, a very simple function, like this, for example. This defen is a macros. We can expand it. Made of def some var. Var is a mutable structure, is a reference type of data, and it provides a mutable value. If var is without any special signs, the system tries to get hold of the value, but we can use this magic sequence. And why do we need this mutability in the world of clean functions? for the following purpose, to be able to reload the code quickly. So we can redo it. So comma EE, I'll explain what happens. It takes this expression and sends it to runtime. Runtime sends it over, and the sunvar shows a new implementation of the function. If we touch it, we see it's new, and then we get a hot reload of the code under the commands from your system. If a different function was sent to this variable, it was in the Russian version, then we redo it to the English version, and then check the function. We see that it has changed. So the program is made of clean functions which can be reloaded. There is no state. The program structure is based on mutable structures, on references that help you reload it easily, and state is somewhere on the side, and you have a chance to reload the hot in runtime. If you have a look at other languages, dynamic languages even, it will be exactly the opposite. The code is very deep inside, it is immutable, your functions operate with mutable data, and there is a state somewhere, and there are objects, and this code cannot be reloaded without hacks because of the blurred state and for other reasons. But what we did, it worked very simple. I have Emacs with simple plug-in. It takes an expression, sends it according to a certain protocol to nREPL server. The operating server just takes the string with the code, runtime evaluates it, and then it returns it. So the whole point is on wrapper server. It is smart. That's why IGE support is quite a simple task. A few words about macros. I wanted to explain this. These are data. We can print this code. We can run through it as a structure. We can mention a type. Also, you can modify the code if you decide to expand the language syntax. You can use simple functions for that. This is the end of explanation of Quazure. I think we spent about 5 to 7 minutes. Let's see how we work with the database from the closure. So we can use a thin wrap for JDBC. Let's get a connection string first, the one reading the variable. Let's have a look what we have. Here, I have Becker Compact. Launched with Postgres 13. So I think we can reach all this. A thin wrapper on JDBC helps us. Wait a second. Send a simple query. We'll go to the database and get this value 1. We can find something interesting, get a list of all tables, for instance, through the information scheme. Someone in Twitter asked how in Clojure we work with SQL. Well, we have uniform runtime here, from which we can send queries. So we can create a table through execute, create a simple helper. Here we have IB, serial IB, data J. When we have JSON in Postgres, we would like to have dynamic data structure. So here we can do the inserts. This is cycle 4. So we do insertions, nothing unusual. So we see the guys here.
Ну вот мы можем смешивать, например, наш средний метрос. Я говорю, что
We
в
can
Quazure есть
also,
сотни функций, чтобы
in Quazure we have dozens of functions.
Получили список, по списку пробежались,
So you can get hold of the list, get data key, hash map, and look through the results.
Можно прямо вот так вот SQL name получить.
You can get it with SQL name.
Вызывать. Вот. Тут, наверное, как бы, ну, можно передавать параметры, то есть через
You can provide parameters or transmit parameters through questions. It's important to mention that it's been a while that we decided not to hide SQL behind some forms, frameworks, because the language is quite expressive and business tasks are implemented very well with SQL. So we decided that in our development, SQL should be the first-class citizen, and big portions of applications are written on SQL, although it is not easy to work with the strings and glue the strings. And it is not convenient to change them in the middle. So the business application, 80% of them are generators of SQL queries. Therefore, in Clojure, we use a classical approach. We don't have classes of objects, we only have types of data, and the only abstract that we have is generic data structures. So in this case, we can try to view the query in this form. So asterisk, person, so some constant lines. If we have this hash map, we can use dozens of operations, hundreds of operations, and do what we need. There is a very small library that accepts this data structure and generates an SQL query. So you can play with it here. So here we add a limit. Here we replace it with ID. We can even write a small helper here to accept GDBC line or string. Or if it is something different, it will interpret it like this. Let's do this. It will be useful. I loaded into runtime this function. So we can make a query, select asterisk. This is end block, a key that is not used. PG format. Copy the query and have a look at it. This name key was used as a comment.
То есть пока мы оставим за скобками, как этот DSL реализован, но на самом деле он очень
We will not explain how it is implemented, but in fact it's a small one, it's one file which implements conversion of this data structure into a string, and this happens quite frequently. We have quite a few libraries, and they replace huge ORMs with a lot of dependencies. So this is a one-file library. So it's a business card of Clojure. So instead of gluing data, we're now moving to data structure. We can write a function. So here we add values. Like this, for example. So we can transmit parameters. Hash maps are written in the reverse order. So instead of withdrawing the key here, we write the reverse order and receive those variables. And here we start building a dynamic query. It is enough to ignore things here. If nothing is generated here, then we write a search function. It shows a query that we get hold of, and we can even add an SQL
перегрузили функцию.
So we reload the function
Вот был такой запрос
and see the
данных.
output.
Такая
So
история
this is
получилась
the
с
data
параметрами.
request, this is the
Получили
SQL with the
такой метод.
parameters, and
Ну и
this is
вот
the
с
outcome.
разными параметрами мы уже можем
So we
записать.
can
Вы
use
уже
different
начинаете, наверное,
parameters,
чувствовать этот динамизм,
and
как
I
бы,
think
свободу,
you
которую вы
can feel
получаете,
this fast speed,
ваш SQL в виде структурки данных.
and you see the SQL as a data structure here.
Так. Да, ну вот как раз, например, когда нам становится больно клеить строчку, когда мы
So
хотим
when we stop liking
наш
gluing
запрос
the
в
strings,
разных
we want to
местах.
modify our query in
Например,
various
давайте напишем
places.
такую функцию, которая вот тот же
Let's
самый
write a
запрос у нас
function
выполняет, но при
that
этом мы,
performs the
во-первых,
same
например, хотим
query,
получить
but at the
count.
same time, we want
В данном случае, чтобы получить вот count,
to get count.
нам достаточно модифицировать
To get
запрос и
count, we
поменять
need to modify the
HTML
query
Давайте даже
and change this section.
ставим пока. Также, например, мы сразу можем кинуть
Also,
analyze. Ну, это может там включаться
we
в зависимости
can
от какого-то
do
параметра.
analyze. Of course, it depends on a
Analyze
certain
мы получим тоже
parameter.
модифицированный запрос,
Analyze
просто добавив как бы
will be
возможность
modified as a
analyze.
modified
Таким образом,
query.
вот из одного запроса мы
Therefore,
получаем 3.
we get 3 queries out of one,
Ну и давайте посмотрим, что у нас
and let's
получилось.
see
Вот, то есть
what
вернулись
we
эти
get.
данные, вот у нас посчитался этот
So
count.
this is the
У
count.
нас даже пришел analyze. Ну и вот
This is analyze.
Вот. Опять-таки, вот, то есть представление запроса в виде структуры данных позволяет его потом
So a query in the form of a data structure can help us modify it somewhere in the end to reassemble it along the way.
Так, вот этот наш язычок, который структуру данных как бы
So this language that ensures data structure, it can easily be expanded. For example, we see repeatable or repeated patterns.
Например, структура JSON-B называется там data.
JSON-B convention data.
И мы из нее постоянно что-то берем там через
So we take something from it through the operator, through arrows. In this case, the format generates this, and we see that this pattern is repeated. Let's expand it and add 2 arrows that would hide this repeated structure. It would be a sort of a macros. Multi-met function. I will not go into detail of this, but this is how we do polymorphism in Clojure. We enter a new character and say that this expression should be used. So you see repeated strings. So our query can now become much shorter. Even if you repeat I like, so this is wrapped, and the whole code receives more expression. So, and now we can deploy it. So you can remove excessive code by doing this. Make queries and build high-level API by introducing something new. So it costs you a few strings. The library itself, for example. Here we see a lot of structures, constructions, we see tests here, and the outcomes. So try to perform them. If you are tired of writing JSON-B built object, you can create a so-called macros. Because it's a data structure, we can turn some portions into SQL, and then they will compose themselves into something more sophisticated.
Okay.
All right.
Вот как бы в этот момент где-то наступает, если вы начинаете мыслить данными, все превращаете в данные.
So at this point, when you start thinking in terms of data, you have enlightenment, and you start think about model-driven, how to describe what I want in a declarative way, and write an interpreter or an engine. It is great to describe it with data, but when you write external or internal DSL, it takes 1 or 1.5 interpreter. But we have a design, for example, for creating a table, which is assembled into such an SQL. This is a data structure. Let's assume we have a description in the form of a JSON scheme, and we want to generate a table according to JSON scheme. Quite simple. Well, these may be types in Postgres, and out of this map we can get, if we have string in JSON scheme, then we can see that it is a text in Postgres.
Now we're writing generate columns function, and we're using reduce to collect these columns. So we've written this function, and by default we inserted ID here. It can be executed here. So we did it, and now we see a piece of the result we need. A piece of this table. After that, we can check our scheme and gather the final SQL. So this is a function. Now we can call this function in our scheme to see the result. Here it is. And actually there can be thousands or hundreds of these instances. You develop this JSON scheme, and after that you checked it and created the tables. You called exact, and this is the table. It is empty, but it has appeared. Another example of these consequences, it seems to us that this step is insignificant, but it has its consequence. Now you can analyze your queries. Data structures are regular. You can check them. For example, how can we offer indices by query? This is a naive implementation. We have a query here, and we want to write a function that will offer us to create an index. And for the index, we have this data structure. It compiles here. So we write the statement of the index. We received table expression. And now we will take this part, analyze this expression, and offer an index for it. This is the key, and we will use it as a part of the index. So we selected the name of the table, the key. We added index here. This will be index name. We started collecting the structure. And after that, we looked at the expression. And if we have an equality here, we enter expression here. If there is I like, we will insert gene here, and we will correct the expression a bit. And we will get the index. So let's see it. So now we check the whole query, and we received two statements. This is just a demo. Of course, in your real life, you will go much further, but it's important that you are moving in that direction. So you are trying to think in a generic manner. I already mentioned that this is SQL, and SQL is represented in the form of data. This is just a part of demonstration of business operations that merge insurance. CTE is used, and in one query, we execute a lot of operations without loading the base. Without further transactions, we prepare it in the form of a single query. This thing can be divided into pieces because now it's quite easy for us to collect functions. We can reuse it in search, for example, in indices. So this is the function. It's quite complicated. It seems complicated, and after that we can collect SQL. We haven't touched the base yet. Another example, a bit more difficult for you to understand the way production code looks like. So this is a smart operation called patching in Postgres, and it actually confirms why we do not hide SQL. So we want to patch without concurrency problems, or without touching the essence itself, and I do not know how you can wrap this SQL. There are a lot of commands here, and writing specific wrappers for all of them is quite complicated. So how much time is left for me?
Ваня, сколько у меня времени?
So, how much time is left? 10 minutes.
Ну, прыгнем и посмотрим немножечко уже на такой
Well,
общий пример.
now I would like to show you a general example.
Когда вы читаете существующий код на клажуре, нужно читать...
When you read an existing code on Clojure, you should read it from bottom to top. Because actually Clojure reads it from top to bottom and it checks the symbols that were already announced. This is a limitation, but this is a subtlety. It actually let redo work. Speaking about web, this is a small library, and we can launch a server. For example, this is our handler. We will comment it, and writing a simple web server is writing a function that will receive a query in the form of hash map, and that will return the response. So this is the response. This is the server. It will answer hello to everything, and we're starting our server. It was already launched. Now we're moving towards our host. It will respond hello to everything. And it's important to reload this function in dynamics.
Okay. На самом деле мы тут сделаем чуть-чуть посложнее, тут немножко helper.
Actually, here we will make it a bit more complicated. Here there are a few helpers, and this query will be in the form of hash map. This query string, we will pass these parameters using this function, and after that we will have request. After that, we call routing, this is dispatch, that will select specific function that will respond to the query depending on the routes. And here there is a helper. So in JSON, we will transform it in order not to repeat it in every handler. So our dispatch function is quite simple. It uses routing that is built on data. So we describe routes by data. This is a sitemap, and if this is a method, then the function that will be responsible for this method, and if this is a string, then we call, for example, big tables. It will mean that this is a way to the inbuilt hash maps, and the routing itself will divide this pathway and look for the necessary node in hash map. So it has divided it into steps, and after that it looked for it on the way to hash map. These are the steps. They can become parameters. So this is a parameter. Anything can be presented in parameters. These are our routes. All the library for routing is from one and the same file. It allows us to transfer this query, and it will find the node in this hash map. So we can select it from here. We can check it, and here it answers us. There is a bit noise here, but it found this function, this select function, and in MS table parameters, we can see the necessary parameter. So this dispatch function is quite simple. It looks for the function that can be moved further. It selects parameters and calls this function, and it returns the response. And for example, let's check our routes. Well, big tables, for example. This is a classical query for 10 largest tables. So these are the data, and the handler itself selects query and returns the response. We do not even need to enter the browser because this is a function. We can select dispatch function from here directly and see the response. If you do not believe me, we can enter it, big tables, and here's what we have.
И таким образом, дальше вот там чуть поинтереснее, например. какой-нибудь динамический.
And after that, it's a bit more interesting. Dynamic select, for example. No space in the table. So what does select do? In our case, it builds this query. So it glues new space with table, builds the query, and executes it. So, for example, here we select tables, formation scheme and tables, or we can select our pub that we developed before. So it responds to us. And after that, it's possible to write Postgres over one day. I think that many of you have seen these products. They have dynamic parameters. So we received the parameters, and let's select the most naive variant. So here we write parameters. We will this section where we get the key that came from the parameters. After that, we use hashmap assert, and that is equal to key v. So this is very primitive. And, for example, here we can search for it by ID. We can state that $ID is equal to 3. So we forgot transmitting it actually. So it's necessary to write it here. We reloaded it, and here it was filtered by 3. Now we removed it. So let's select 5. Of course, this is just a demo, but I hope that you can see what I'm entering. I guess that you understand the meaning. These are the parameters. And we only had to write 2 or 3 strings for it. At first, it looked quite crypto, but after that, we get used to it. So we called reduce function, selected parameters, and we started gathering this structure of query. By default, this is an equality, but we can get a smarter thing. We can parse parameter at I logged more or less, and it will be interesting for you to reproduce Postgres. And this is the way we develop it. The things that you are saying right now actually is not really different from the way we work in production. So, but the only thing is that we use a test-driven. Well, in this case, it's possible to call directly this dispatch function, and if we write a test, we write SR status, for example, 200, and what we have inside. Our one file library that lets us match this data. So you start writing these points, you open them with tests and get them from REPL. You fix them and you return. I guess that now I can finish my presentation and I'm ready to answer your questions. Well, first of all, I would like to thank Nikolai for his interesting presentation, and I apologize for mixing you up with the USSR Prime Minister because your family names are very similar. I would like to remind the participants that you can ask your questions on the chat if you want to ask a question of the speaker. And now I would like to move on to Q&A session. So probably I did not understand you correctly, but taking into account the working with DSL and data structure, is it right that when you work with Clojure, the objective of Coda is to write a pseudo-array for working with data that will be written on functional language without data mutability? Well, that's an interesting question. It's difficult to code an OR-M because we do not have any objects, we only have hash maps and primitives, but calling it a library that will help you put this query on a higher level, adding boilerplate, yes. In Clojure, well, you've seen actually these routes in web, SQL, and actually everything can be expressed in data if you want to do so, and you write several interpreting functions. And what is good about data compared with inbuilt DSL probably I mentioned it as well. Data can be interpreted differently. So you can write a lot of interpreters. For example, on JSON scheme, I wrote an interpreter that builds tables. And if you realize this aspect, you can describe this model, your DSL, and by it, you can do anything. You can generate documents, you can generate tables, you can analyze queries. So when you use this metadata, this model data, you can do it. And after that, an enlightenment comes. You start seeing the metrics, models, and the interpreters. All your program is a set of models in the form of data and a lot of interpreters. And I would like to ask a question on my behalf. Pure function is good. Java transaction architecture. Have you tried using it? For me, it's interesting. How is it possible to use it in JS? I mean, binary transaction. Or, speaking about some libraries, how can you use it with a library? And how difficult it is? Well, it's not difficult. Actually, we can just use it in Java. A lot of Clojure libraries are just a wrapping on Java, which we've just seen JDBC, but it's possible to make it more beautiful than Java has it, and we can discuss it. For example, if you manage to express your transaction in the form of data, in the form of intent, then it is possible to use a lighter double-phase transaction if you can write your logic in the effect that hadn't been applied yet, or you can make a rollback on this effect. In that case, you become more free. And it would also be interesting if you could compare the option of data working offered by Clojure and just Joke and criteria. And what are these? These are TPE view of queries. Well, I can compare it. In each of these operators that we've just seen, it's possible to wrap them into a specific function or a type, providing validation, but it will take you a lot of time. In this case, this library that I've showed you, that does everything, you can just open it right now. Can you see my screen now? Yes. So, the whole library, all these constructions, it has 1,000 strings only. Actually, we can remove this thing. This is 700 strings in one file. And it's easy to have an extension for you when you use 2 or 3 strings. If you see boilerplate that is repeated in SQL, you can extend it. So this is the issue of efforts in Clojure. We work inside the metrics. We only have these functions. Another important aspect is transparency, being open. Sometimes you merge DSL and this generic data can be mixed. So you start merging DSL, and at that point it might happen that SQL is mixed with security checks, for example, and open data can be mixed easily, but specific type data are not mixed. And using the example of DSL that we used in web, I can show it to you.
Вот, у нас тут были роуты, так, например.
So here we have routes.
Я бы, например, мог придумать, захотеть сделать такую штучку, сказать, что вот у меня тут есть
And for example, I can say that here we have a query.
Get, и здесь просто положить запрос.
Get, and here I can place the query.
И придумать еще язык там какой-нибудь.
And I can devise a language that will give me the parameters. So this is declarative. Here I mixed 2 DSLs, one for routing and the second one for our queries. And I could also add here security check, access policy, and DSL for access policy can be used here as well. And the interpreter is written directly generic candle that takes this node of these roots, selects a query, and executes it, or it can call access policy. Unfortunately, in specific type languages, you will not be able to mix up these things. So at some point, when you want to mix it with something, it will not be mixed.
So the idea of dynamism and openness is good. So we can let the user do this and keep it in Postgres, and the rules will be loaded from the database. There is a joke. Any system strives to become an interpreter. It becomes smarter and smarter. The user wants to add additional settings. Well, you need to learn to limit yourself. Well, I remember a report on Postgres for hipsters. What made you release a new version? No, JS on Clojure, we've never done this. For hipsters, there was a Java conference, and I spoke their language, the language of hipsters. As far as JavaScripters are concerned, they're all invited to get tried. This will be a new turn in the spiral of development. When there were no Java developers, JavaScript developers, JS could have turned into Clojure if it was minus minus, but it is now being turned into plus plus. This happens with many languages, unfortunately, and which expands capabilities without limit. But this is a unique situation. That gentleman took 2 years off and wrote this language. As far as Clojure is concerned, in the past 10 years, there has been no breaking change. So the author wrote the language so well, there was no need to introduce any breaking change. So they update libraries, but they don't include anything else in it. Well, maybe Java can be compared with Clojure. All right, I think you can move now to the spatial chat to interact with the speaker. So there is a button indicating the spatial chat. So please move there. It will not be broadcasted, but you can directly talk to the speaker. So this is the end of our Q&A session. Thank you for the questions and answers. We have a break till 11:45. See you then.